Hey guys, this is Abhishek Shah and Utkarsh Devgan, and we have made a slideshow presentation for our ML third assignment with the topic detection of malicious tweets using NLP. We feel that this topic is so relevant because of the increased growth in social networking in general and Twitter in particular. And with the increased popularity of such sites, there is an increased growth in spams and other phishing techniques to infect the computers of users. We use real-time techniques for detection of such malicious tweets and spams, such as linguistic methods and statistical analysis. In 2010, this direct message was spammed to many users with a link leading to a phishing website. The main objectives are to focus on the detection of tweets containing spam instead of just detecting the spam accounts. Detection of spammers is related with the detection of existent spam accounts. Language models are probabilistic methods used in areas of speech recognition, machine translation, part of speech tagging, parsing, and information retrieval. Statistical language models capture linguistic features hidden in text, like the probability of words or word sequences in a language. A statistical language model is a probability distribution P over strings S that attempts to reflect how frequently a string S occurs as a sentence. The idea is to examine the semantic language used between the tweet and the page link from the tweet to find a divergence value. We use the Kullback-Leibler divergence method. So if we get a zero similarity value, it means that the tweet and the page link between the tweet are totally relevant. But if we get a positive value, it means that there may be some point of irrelevance.
Group together. The second one is the spam labeling, in which a tweet is labeled spam or non-spam depending on the several previously blacklisted tweets in the data set, which is extracted from different APIs. And the third one is the feature extraction, in which the tweets are represented a uh, as a label using NLP and the content analysis techniques. The fourth one is the classifier training, in which the labeled set of tweets and each tweet represented by a set of features is used by the classifier to train its model and acquire necessary knowledge in the detection of spam. The fifth one is the spam detection. The classification algorithm obtains a tweet from a user as an input and notes down the following feedback from the user, whether the tweet is spam or not, according to which the system updates its class according to the user. Now, before classifying any tweets into a spam or not non-spam, we need to pre-process the data set that we have already collected from the different APIs. If the link, any link is present in the tweet which is in the data set and classified as spam, the tweet would be classified as spam also. Now, to identify spam tweets from the crawl dataset, we need some resource beforehand. So here are the list of all the APIs that are used to retrieve some data related to the tweets. The first one is the Google Safe Browsing, the traditional API used by Google. Second one is the Capture HPC honeypot. The third one is the SERP-L, the project honeypot. And along with this Twitter also provides some flagged URLs to label any tweet. So a language model is basically a statistical model for text analysis over the different words which are contained in a sentence, and these models are used to evaluate the likelihood of those words in any sentence. In any case, when the real model of a language is unknown, We can estimate the difference between those texts by evaluating the probability distribution of those texts and then comparing the models of those. In the given paper, three language models are being used. One is the tweet, the other one is the thread of tweets which are coming from that particular tweet, and the third model is the page to which the tweet directs to. One of the most important methods to find the differences between the distribution of two models is the Kullback-Leibler divergence. There are two variants for this method. The first one is used for the discrete distribution. The second one is used for the continuous distribution. In our case, we are going to use the discrete one. Here are some notations regarding the calculation of the probabilities. Pi is basically the probability of a term I in the first text unit. Qi is the probability of the term I in the second text unit. These probabilities are smoothed with the Jelinek-Mercer method. And there is an influence factor lambda, which basically gives importance to one model over the other one. We have two probability distributions. The one is the probability of thread, probability of any term on a particular thread. The second one is the probability of a particular term t in the tweet, where the ML thread, which is basically a maximum likelihood probability in the beta distribution of the term t. So to find the best set of features, we basically try to plug in different features and try to calculate the divergence between the tweet and the page linked with the tweet. The effectiveness of these features is very high, but on the other side the computational cost is very high, because the system then would have to download each and every page which is linked from the tweet, and it would take an ample amount of time. For this reason, the title of the page is also analyze. This comparison is very useful. We can also reduce the time by making the HTTP request lighter, so that we won't have to retrieve the full page, the full information.
The features extracted are number of URLs per number of words, number of hashtags per word, number of words, number of characters, number of URLs, number of hashtags, number of numerical characters, number of words from a list of spam words, number of times the tweet has been replied, number of tweets posted in the thread by the same user, time since the last tweet posted by the same user. Classification of performance. Precision. It is the fraction of spam classifications that are actually spam. Recall is the fraction of actual spam tweets that are classified as spam. F measure is the measure of a test's accuracy and is defined as the weighted harmonic mean of the precision and recall of the test. Accuracy is the fraction of total classification that are classifying actual spam as spam and actual non-spam as non-spam. A system is designed to get the most benefit from the extracted features, adapting the analysis of language to the main characteristics of the tweets, and particularly the trending topics. Thus, a system can be applied to spam detection and trending topics in real time, mainly because the system focuses on the detection of spam tweets instead of spam accounts. You can refer to the original journal using the website link given.